Okay, engineering students. Let's proceed from where we left. We're looking at the isomers of butane in this case. In this case, we're saying that if you have the two hydrogens on the same side of the double bond, like in this case, which I've shown here, like these hydrogens are white, and then like the methyl groups are red, then this one is called cis-butane. Yeah, cis-butane. You can see the red one as being methyl. This methyl, that's the double bond, and the hydrogens are down. Yeah, and then if they are across, like in this case here, the red ball and the red ball, they are down, something like that. This is called trans-butane. Yeah. So, as I mentioned in the previous video, is the fact that that biologically the alkenes that are found in nature mostly contain hydrogens on the double bond. So, most of them being on the same side, some being across. Yeah. But later I think we'll see how the hydrogens being on the same side or across is going to affect biological activity. Yeah, we'll see. By biological activity, it means that that the alkenes which have got hydrogens being on the same side are going to be affected differently by things which are going to call enzymes. Enzymes are biological catalysts. The way they are going to affect the alkenes with the double bond on the same side and those being across, but that one you're going to see later. But now, as industrialization, I think in the 1800s continued, scientists began to create compounds which are not available in nature. For example, rather than just come up with alkenes that contain only hydrogens across, they started adding other groups. Maybe they would even add alkyl substituents, or maybe what do you call even atoms which are not hydrogens, or even the ones containing carbon. Just for example, take for example like in this case, there is the methyl group. The red one is the methyl group. This is the methyl group. This hydrogen. But what I want to do is probably put in another atom. For example, like let me put a green ball here, representing another functional group. It doesn't really matter whatever is the functional group. Yeah. Now, what are you going to call this? Are you going to say the hydrogens are on the same side of the double bond or across? Yeah. In this case, it will be neither. There is only one hydrogen, or sometimes you may not have a hydrogen even on the double bond. So in this case, you need to come up with a new way of identifying that alkene, and this is what the scientists they came up with, and this is the nomenclature which I'm going to talk about. It is called E/Z nomenclature of alkenes. Yeah. So this means that depending on the arrangement of atoms around the double bond, you are either going to call it an E alkene or a Z alkene. Now, somehow, okay, this nomenclature was brought about by Germans. Yeah. Yeah. So they're the ones who came up with this, and the actual full name in the E or the Z, they are actually in German, and therefore I will not give those names, but but they sound like this. Entgegen for the E means uh, across, as opposed to ZB means zusammen, yeah? But I'll come to that one. Okay, let me just try to get. There is the double bond. So there is the E, and then there is the Z. And I think I've got that one, and then okay, I'll just try to get the exact spelling, but there is one for German being on the opposite side, one being on the same side. I just wanted to get the exact okay. Okay. Now, I just want to show you that there's some difference in the way we are having, like the one for the cis electrons. In this case, we're just saying we're looking at the double bond as being across here. This is the double bond, and in talking about the cis electrons, what we're doing, we're coming up with an imaginary horizontal line. Can you see there is the line which I'm calling like the it's visible there. It's a horizontal line, and in that horizontal line, these two hydrogens, they are on the same side. And if I was to show that line, it means that these hydrogens, they are across. They are what? They are across. This one, they're on the same side of that horizontal line. These ones, they are actually across, yeah, on opposite sides of that. Just like an equator, yeah. That there is an equator, yeah, and then there's one on the lower hemisphere, and the other one on the okay, this one could be the southern hemisphere, this could be the northern hemisphere, yeah? If you have to look at it geographically. As opposed to this one, we can say they are either both being on the lower hemisphere, or both of them being on the northern hemisphere, the southern or the northern hemisphere. Just to give an example of that. But now, if you're dealing with this kind of nomenclature, it is more universal, and they came up with another way, because in this case, you're not going to be having two groups, like in this case, hydrogen as either being on the same side or across. What they did was to look at the group. Maybe I call it, I'm using the word HP, I'm using LP, and probably call it HP, and this one I call it LP. And then in this case, I'm going to call it HP. This one I call it HP. This one I call it LP, and then LP. Okay? Can you see? So this is the simplification in which the Germans brought. Let me come this side. Now, HP is just going to mean high priority. High priority. LP is going to mean low priority. So that in this case, I'll say you have two high priority groups on the same side, and then two low priority groups on the same side. So if you're going to have such a situation, are you going to call it E or the Z? We'll come to that one. In this case, you've got two high priority groups on opposite sides. High priority, low priority, low priority. Are you going to get? So that in this case, this one can be used on any type of alkene, provided you come up with rules and say, these are the standard rules in which we are going to identify, hey, among these two groups on the same side, okay, now you're going to say, in this case, there will be a new dividing line. Can you see here, there was the horizontal line. when you're dealing with the EZ nomenclature, there will be a vertical line. There is a vertical line. Can you see? There's that vertical line. So on the left side of the horizontal line, you're going to be looking at the priority of the groups on the left, and then you compare with the priority of the groups on the right. Can you see now? This one you're now dealing with a vertical line, yeah, a vertical line. So you're going to be comparing the groups on the left or on the right. So the thing is this: if you're going to have two high priority groups on the same side, and then two low priority groups on the lower side, so this one will be called a Z alkene. It means that that the high priority groups, they are on the same side of the double bond. In this case, you've got the low priority groups also on the same side. If you're going to have high priority groups on opposite side, so this will be called an E alkene. Okay? All right? What you're going to see is this form of nomenclature can also be used for the cis-trans alkane. Let us see how we can use it. Let's try to redraw what we have here. Like I've got my CH3 group, and then I've got my hydrogen here, and then I've got my CH3 group here, and then I've got my hydrogen, and then I've got another CH3 group here, and then I've got my hydrogen, and then I've got my CH3 group here. Now there are those rules which exist in your lecture notes, but I think I'll just summarize here that if you're going to have an atom or a group, okay, in this case, perhaps this may be clear. Rather than draw those carbons, those methyl group like that, and just draw my carbon, and then I attach my hydrogens like this, so that it's going to make sense, yeah? So in this case, your focus will be on the atom attached to the double bond. In this case, the atom attached is carbon. And carbon has got a higher atomic number, which is, the atomic number for carbon is 6. For hydrogen is 1. So carbon has got a higher atomic number than hydrogen. And therefore, this group containing carbon is going to be said to be a high priority, and the hydrogen will be taken to be the low priority. So I'm simply going to put here high priority. I'm going to put low priority. In this case, the hydrogen will be low priority. This will be hydrogen. This methyl group will be high priority. So you're going to have two high priority group on opposite side. So this will be an E alkene. Okay. And the same thing here. This one contains carbon, and this one contains carbon, and you've got two high priority groups on opposites on the same side. So this will be a Z alkene. Are you okay? Yeah, so this will be a Z alkene, this will be an E alkene. Have you seen that? So this form of nomenclature can be used universally. And I'm just going to show you some more things regarding that one, so that you'll be able to come up with ways of really classify alkanes as either E or Z. So I'm just going to delete some of this and then put some examples, and then we'll show them as either E or the Z. So let me see. I've got what? Okay. and then I've got a what? Probably I've got I'm just trying to put many variables there. I hope probably I've got what? NH2. Okay. Now, there is a point here I'm just trying to drive at, but once again you'll get the full list in your notes. This is a hydrogen. Can you see here? This is a hydrogen attached to the double bond. And then here I've got an isomer of hydrogen, which I'm going to call deuterium. Deuterium is similar to hydrogen in that it has what? It has a proton and one neutron. The other isotope of hydrogen is tritium. Yeah, hydrogen, deuterium, tritium. So if you are going to have the same number of protons, it means that you are talking about the same element. Let me use the word element, like in this case hydrogen. But then you're going to have isotopes. So the isotope with the higher atomic mass is going to be said to be high priority. So deuterium will be high priority. Hydrogen will be low priority. Can you see that? The high atomic mass for the same element, that means it's higher priority. So which other elements? Common elements do you know which exist in those isotopes which you can put as high priority and low priority? You are right, carbon. Well, so there is carbon 12, which is the normal carbon. There is carbon 13, and then there is carbon 14. Which other element? There's something like what? Phosphorus. It exists as isomers, enantiomers, and also chlorine. Yeah, chlorine 35 and chlorine 37. You are aware about that, yeah? So all of these isomers, they can tell you that the isotope with the higher mass is going to be said to be high priority, and the one with the lower mass will be said to be low priority. Now, on this other side, I've got an example here. Both of them have got carbon attached to the double bond. This has got carbon attached to the double bond. In that case, what you do is that you look at the other atoms around it. So that in this case, this carbon has got hydrogen, hydrogen, hydrogen. This carbon has got a hydrogen, hydrogen, and then there is a methyl group attached to it. So the presence of a methyl group other than the hydrogen makes this group being more high priority compared to this other one here. So on this side, this one will be high priority, this one will be low priority. Are you seeing here? And on this other side, the hydrogen is low priority, this is high priority. So we'll come up to on how to name those alkenes. Later we'll come to the nomenclature of alkenes. But for this one, we'll just say you've got two high priority groups on the same side. So this will be a Z alkene. Have you seen that? All right. Now, let me look at this example here. Yeah. On this side, there is a carbon attached to the double bond, and then that group is very complicated. There's a methyl group, a methyl group, a methyl group, but then attached to the double bond on this side, there is a what? There is an hydroxy group, oxygen, and then oxygen and hydrogen. in this case, you've got, on this other side, you've got your nitrogen attached to two hydrogens, and then you've got a long chain of carbon, carbon, carbon here. Have you seen that? So let's look at this other side, yeah? You're going to be considering the rule of the element with the high atomic number. This group is very large. If you're talking about the atomic mass, this could be probably 30, 40, whatever, as opposed to oxygen has got an atomic number mass 16 16 plus hydrogen is 17, yeah? So this is just a small group. But the oxygen has got atomic number of 8, yeah? As opposed to carbon has got an atomic number of 6. So irrespective of how big a group is, if the atom attached to the double bond has got a low atomic number, it is said to be low priority. So this is low priority because of the low atomic number. This is high priority. Have you seen that? Now, the same thing about this one. Nitrogen has got an atomic number of 7. This is carbon, which has got atomic number of 6. So even if the group attached to it is quite large, but the atom attached to it has got a low atomic number, this will be taken to be low priority. This one will be said to be high priority. So you've got two high priority groups on opposite sides. So this will be an alkene. Alright? So this will be an alkene. Excuse me. This will be a Z alkene. I'm sorry for that. So so this is to show you the difference between we've seen E and cis and trans alkene, and then E and the Z alkene. So we're just going to take a short break, and then when we come back, we'll see how we can name alkenes with the substituents. We are going to name alkenes with the substituents. So we're just going to do the same thing that we did with the alkenes, whereby you've got an alkane with substituents, and then you're going to come up with a name. But for now, we'll just try, in coming up with names, excuse me, we'll try to avoid the ones containing other atoms like the oxygen and the nitrogen and the rest. And therefore, we are only going to focus on the alkenes containing carbon and the hydrogen as the substituents. Yeah, you just follow up. It's just that simple. Two high priority groups on opposite sides, E alkene. Two high priority groups on the same side, Z alkene. Now, this naming of the E and the Z applies to all what? No. I can't say it applies to all alkenes, because there are exceptions. Let me show the exceptions before we take a break. Let me show the exception. For example, I've got a CH3 group here. I've got a CH3 group here. Let's say I've got a CH2, CH2, CH3. Then I've got probably something like that. You understand, yeah? So on this side, it will be clear that on the atom attached to here is highly branched. Therefore, you can say this one has got a high priority compared to this one. So you can say this is high priority, this is low priority. But when I'm coming to this side, what can I see? There is a methyl group, there is a methyl group here. So a methyl group here and a methyl group here, I cannot say one methyl group has got a high priority compared to the other one. So the other rule which I'm going to bring is that if you are going to have two similar groups on the same side of the double bond, yeah? You understand this? It's like a latitude, yeah? So either on the left or the right, if you're going to have two similar groups, then you cannot use E of the Z. E of the Z can never be used. So in this case, you are simply going to name your alkene without putting the name E of the Z before. Now, I think before we take a break, is that if you're having E of the Z or the cis of the trans, usually put something like the E in bracket before, like you're going to put an E before or the Z before, or if it is cis, you're going to put a cis, cis, and then you put the name of the alkene. Or sometimes some people may put cis in bracket, yeah. But in this case, somebody can put just something like the cis or the trans alkene, and then the name, right? So, but the E or the Z usually put it in bracket, E or the Z before, and then you put the dash. Usually we normally use the capital letter, like the capital Z and the capital E. Yeah. So we are going to take a break, and then we'll now come prepared to see how we can look at the final section on the naming of these alkenes, yeah, according to the IUPAC nomenclature. I hope you've enjoyed this course. It's getting a bit excited, yeah? It's getting excited. So you're going to really enjoy this section of the course. So thank you very much, yeah, for listening.